In a covalent bond, the elements share the electrons equally. In a polar covalent bond, the one element hogs the electrons. In an ionic bond, one element loses its electron to another element. That element becomes positive and the other one becomes negative, and they both have complete valence shells. You can determine the type of bond two elements are going to have by the differences in their electronegativity value. If the difference is between 0 and 0.5, it will be covalent. If the difference is between 0.5 and 1.7, it's going to be polar covalent. If the difference is between 1.7 and 3.3, it's going to be ionic. As you move to the right and up a group in the periodic table, the electronegativity, ionization energy, and electron affinity all increase. However, as you move left and down the group in the periodic table, the atomic radius increases. In a synthesis reaction, two elements come together to form a compound. In a decomposition reaction, those elements split apart. In a single displacement reaction, one element reacts with a compound to form a new compound and displace one of the elements. In a double displacement reaction, two compounds react together, and they switch partners. In a neutralization reaction, an acid or a base has a pH of 7 in the end, which is neutral. In a combustion reaction that is complete, CO2 and H2O are formed. The limiting reactant is the one that produces the least amount of product. To find the theoretical yield of a reaction, you use this chart to find the lowest amount of moles, which is the limiting reagent, and then you find the molar mass, and then you use the molar mass and the moles to find the mass, and that is your theoretical yield. To find the percent yield, you have to actually do the experiment. And then you take the actual mass, then you divide it by the expected mass, the theoretical yield, and times it by 100%. First we have the normal way we do it, which is moles per liter. The moles of the solute divided by the volume of the solution. Then we have mass concentration. The mass of the solute divided by the mass of the solution. Then we have parts per million concentration. The mass of the solute divided by the mass of the solution times 10 to the 6, or a million. Parts per billion is kind of similar to parts per million. Mass of solute divided by mass of solution times a billion. And density equals mass over volume. The empirical formula shows the simplest whole number ratio of elements in a compound. You use a chart like this to find the empirical formula. If the ratio is C1H2, then the formula is CH2. But the molar mass is 14.3 grams per mole. If the actual molar mass is 28.06 grams per mole, you divide the two. Then you times that answer by the empirical formula to get the molecular formula. Acids have a pH greater than or equal to 0 and less than 7. They often taste sour and feel sticky. Bases have a pH greater than 7 or equal to or less than 14. They often taste bitter and feel slippery. The solutions stoichiometry chart and the acid and base stoichiometry chart is similar to the regular stoichiometry chart. The only thing that's different is that you add the molarity, which is moles per liter, and the volume, which is in liters. According to Boyle's law, P1 times V1 equals P2 times V2. According to Gay-Lussac's law, P1 over T1 equals P2 over T2. According to Charles' law, V1 over T1 equals V2 over T2. And that's too complicated to remember individually, so we remember the combined gas law, which states that P1 times V1 over T1 equals P2 times V2 over T2. But then we have Avogadro's law, which states that V1 over N1 equals V2 over N2. So we think of a new gas law, the ideal gas law. The pressure times the volume equals the moles times the gas constant times the temperature in kelvins. If you're dealing with a pressure in kilopascals, the gas constant is 8.314. If you're dealing with a pressure in ATM, then the gas constant is 0.0821.